Get with it, let's get down with learning. Drop it low cause the flow is burning. Up, take it to the window, take it to the wall. Cause you know it's time for roll call. Bumpin' Brad bustin' down with his beats. They gonna make you hop out and get out of your seats. Jumpin' Jess hip hopping around. Watch her bust a move to that brand new sound. Moving mouth, breaking down on the floor. Doing all the things you ain't never seen before. And last it's me, I'm Mixmaster Mo. You know I'm coming through with that ice cold flow. It's true that the more that you know will help you get your big old brain to big grow. So buckle up kids, it's a science show. And you put it all together and you get low. Hey kids, it's Mixmaster Mo here with another sizzling science topic, and today we're going to be talking about kinetics. Now, you may have heard of kinetic energy, which is the energy of motion.
Hey, not in the lab. Kinetics is the study of the rate of reactions under various conditions. As a chemical reaction happens, the amount of reactions will decrease and the amount of products will increase. The rate of reaction is essentially how fast the reaction proceeds.
But there's things that affect our rate of reaction, and today we're going to look at how the concentration of the reactants affects our rate.
It's important to understand that the rate of reaction can be changed so that we can measure and control reaction rates, and scientists can use that to create products we use every day.
Hey guys, so here's what we're going to need for today's experiment.
And my favorite part are chemicals. And that's all we need for this experiment.
Wait a minute, Jess. These chemicals are some seriously toxic stuff, so we gotta make sure we have on our gloves, goggles, apron, and whatever else you need to make sure you don't have your hair or skin exposed.
So the first thing we've done is labeled our 3 flasks. This is very important. The next thing we're going to do is fill each flask with 75 milliliters of our dextrose solution. Just like that.
Next, we're gonna add 4 drops of methylene blue solution to each flask. So next, we're gonna get a clean, graduated cylinder and add 25 milliliters of sodium hydroxide solution, as well as 50 milliliters of distilled water to the first flask and swirl it all together.
For flask number 2, we're going to add 50 milliliters of our sodium hydroxide solution and 25 milliliters of distilled water. For flask number 3, we're going to add 75 milliliters of our NaOH solution.
Now we have to let the flask sit and wait for the color to fade. So you know what that means? Dance break! Hold up, crew. It looks like it's go time. So here's what we're gonna do first. Let's cover the flask with the parafilm so nothing spills out. So now I'm gonna get Jess and Mo to help me out here. What I need you guys to do is when I say go, we're gonna shake these 3 flasks 10 times.
All right.
Are you guys ready?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Before the experiment, we said that the rate of our reaction would be indicated by the speed at which the color changes. Well, to understand this, we should look at the 2 reactions methylene blue solution undergoes.
When the methylene blue is combined with dextrose and sodium hydroxide, it becomes colorless. But when the colorless form of methylene blue is combined with oxygen, O2, which happens when the flask is shaken, it turns blue again.
If all 3 flasks are shaken at the same time, they should react at the same rate. But remember, there are different concentrations of sodium hydroxide in each flask. Flask 3 has the greatest amount of sodium hydroxide in it and takes the least amount of time to become colorless. And flask 1 has the least amount of sodium hydroxide, which means it'll take the longest to become colorless.
When the mixture is shaken up, the increased number of molecules increase the number of collisions. More collisions means more successful collisions, which means the reaction proceeds at a faster rate.
And that sums it up for today. We learned that concentration is one of many things that affects rate of reaction, and we saw that through a color-changing reaction. Overall, kinetics really kicks. See you next time.